Okay guys, going to do another one in this method. So we've got W of t measures the depth of a river, and it's a piecewise function. It's given from 0 to 10. So we want to know, is W of t continuous at t equals 6? All right, so there are a couple things. First thing, we want to know what's the limit as, not x's, it's t approaches 6 from the left. And then we want to know what's the limit as t approaches 6 from the right, because 6 is the place where it breaks. So we want to know what's the limit for this one and what's the limit as it approaches 6 for this one. So I'm going to plug 6 into my top one. So I get 17 over 2 minus 3 over 2 cosine of pi times 6 over 6, so that's cosine of pi. So cosine of pi is the x value at pi, so that's -1. So that's going to become 17 over 2 plus 3 over 2. So that's 20 over 2, so this is going to equal 10. Okay. So the limit as it approaches from the right, we're going to plug 6 into this one. So we get 10 minus 1/5 times 6 minus 6 is 0 squared. So that's going to equal 10. So does the limit as t approaches 6 exist? Yep, it exists. It equals 10 because the left-hand limit equals the right-hand limit. The second thing we check for continuity is, does W of 6 exist? Whoop. All right, so W of 6, well, yep, 6 is equal to it here, so I would plug 6 in here, and I would get, yep, that it equals. And the third thing is, does the limit as t approaches 6 of W of t equal W of 6? And so the limit is 10. Would the value equal 10? Well, yeah, if I plug 6 in up here, you're going to get 10 as well. So, yep, therefore, W of t is continuous at t equals 6. So for continuity, you have to check that the limit exists there, that the value exists there, and that the two are equal. Okay? Find W prime of 8. So 8 falls under the second category, so I'm going to have to take that derivative. So take the 2, bump it down. Keep the inside the same. Then I subtract 1 from the exponent. Then I multiply by the derivative of the inside, which is just 1. So W prime of t is equal to that. So we're going to plug in 8 now for W prime of 8. So we get -2 over 5 times 8 minus 6 is 2. So we get -4/5. Using correct units, explain the meaning. So if W is feet and t is time in hours, this is going to be feet per hour. Okay, so that's feet per hour, and that is the rate, because derivative is the rate, at which the depth of the river is changing. And then the other thing we have to put in is at the time. So it's the rate at which the depth of the river is changing at t equals, well, the time that we're talking about here, 8. Okay? All right, find the equation of line tangent. We need 2 things for an equation of line tangent, point and slope. So I need my point. So 3 comma, I'm going to plug 3 in up top. So I get 17 over 2 minus 3 over 2 cosine of pi times 3 over 6, that's going to be pi over 2. Okay. And so then that's going to be the x value at pi over 2 is 0, so it's going to be 17 over 2. All right, and then we need our slope. So for my slope, I need the derivative at 3. So I need to take the derivative of the top one because 3 falls under that top one. So it's going to be negative 3 over 2. Derivative of cosine is negative sine, so plus sine of pi t over 6 times the derivative of the inside, which is pi over 6. So then we multiply and we get the derivative equals pi over 4. And the reason why I get pi over 4 is I'm just doing 3 pi over 12. And then sine of pi t times t over 6. And then I'm going to plug in 3. So we get w prime of 3, the slope at 3, is equal to pi over 4 times sine of pi over 2. The y value at pi over 2 is 1. So my slope is pi over 4 times 1, pi over 4. So my equation of the line tangent is going to be y minus 17 over 2 equals m pi over 4 times, this is t that we're dealing with here instead of x, t minus 3. And we're technically dealing with w, so I'm going to just change the y to be a w so it's appropriate. Okay? So it matches with our equation because we're not dealing with x's and y's, we're dealing with w's and t's. Okay, so I want to approximate it at 3.1. Drop in 3.1 for t. So it's going to be 3.1 minus 3, that's 0.1, times pi over 4. We're going to add 17 over 2. And that's what w of 3.1 is approximately equal to. I'm not even going to simplify that. I'm not even bothering. There's a pi there. There's decimal and fraction being multiplied. This is good enough for that AP. And this is my equation of the line tangent above it. All right, last part. We've got find the limit as t approaches 2. First thing we do is we plug in 2. You see on that denominator? 2 minus 2. I'm getting a bad feeling about this. W of 2. So I plug 2 in up top. So I'm going to do that up here. 17 over 2 minus 3 over 2 cosine of, so 2, that's going to be pi over 3. Okay, so cosine, the x value at pi over 3 is 1/2. So that's going to be 17 over 2 minus 3 over 4, because 3 over 2 times 1 over 2 is 3/4. Okay? So we get, change that, multiply top and bottom by 2. 34 minus 3 is 31 over 4. So W of 2 is equal to 31 over 4 plus 2 to the third is 8. Oops, sorry, that should be a minus. Minus 8 plus 1/4. Oh no. So this is 31 over 4 plus 1 over 4 is 32 over 4, which is 8 minus 8 over 0. Oh, all that work. 0 over 0. That is not good. All right, so we're going to use L'Hopital's rule once again, which says if you have the limit as x or t approaches something, you get 0 over 0, infinity over infinity, you can do the derivative of the numerator over the derivative of the denominator and do that limit once again. That's L'Hopital's rule. So w prime of t, that's the derivative, minus 3t squared. Derivative of 1/4 is 0. All over derivative of t is 1. Derivative of 2 is 0. So now we plug in 2 again. So I want w prime of 2 minus, and then plugging into 2 squared is 4 times 3 is 12. So we're going to get an answer here. All right, so we're going to do w prime of 2. So I need to do the derivative of this top one. All right, we already did the derivative over here. So what I'm going to do is just plug 2 into this right here. So we've got 3 over 2 sine of pi times 2 over 6 is pi over 3 times pi over 6. All right, so we've got the y value of pi over 3 is radical 3 over 2, so this is 3 over 2 times radical 3 over 2 times pi over 6. Could I multiply them and simplify? Yeah. Do I need to? Nope. Minus 12. Boom. That's what my answer is using L'Hopital's, because it's not 0 over 0, so that's good. All right, and that's it.